Okay, algebra. I think my recording is going to work, so hopefully this goes. We are doing the second half of 7-2, adding and subtracting. So yesterday we did least common multiples and finding like the common denominator thing for things that were trapped and things that were not trapped. Now we're going to actually be doing the additions. So we have like 3 problems down here. These 3 problems down here to go through. We're going to start by going through with just a fraction addition problem, just to kind of get our feet wet. And then this back side, I'm going to show you as soon as I get done going through the homework and explaining. So if you want to see that, this is going to be like bonus material back here. So I'll go through that at the end of the video. If you are tapped out and you are done and you're already a little confused, don't listen to this, okay? So here we go. Let's go through these 3 examples, 3.5 examples, I guess, starting with this guy. So put him off to the side of example 2, just to kind of show you the process of how we add common denominators. This is like what you learned in, like, I don't know, 5th grade or whatever, whenever you started to do that, okay? So what we're doing when we're adding these fractions together is we're trying to find a common denominator or a least common multiple with 6 and 4. And I understand that 6 times 4 is 24, but 24 is not the least common multiple. We want an LCM, a least common multiple. I want a small number that 4 and 6 go into. So I'm not going to use 24. I'm going to use instead 12 because that's a smaller number that those 2 will go into, okay? All right, so this is going to be very, very similar to the process that we're going to eventually do over here when we have x's and y's, okay? So we've got 12s. So I'm going to start with this, and I'm going to say, what do you multiply by 6 to get 12? Okay, and I'm going to write that off to the side over here, and I'm going to say you have to multiply by 2. So I'm just going to say times 2. And what I'm going to do is I'm going to take 1, and that means I'm going to take 1 times 2, right? Okay, so that's how that works. And 1 times 2, if you want to just write 2 up there, that's fine, okay? This guy on the right side, what did we take times 4 to get 12? Like from here to here. That's times 3. Okay, so we're going to take this top number, 3, that we had originally, times 3, and that's going to give us a new top number of 9. And then all we do is combine our like terms together, and so our denominator is going to be 12, and then 2 plus 9 is 11. So we have 11 over 12 is going to be our answer. Okay, keep in mind the 12 that's on the bottom, you don't add those together to make 24. That number stays the same, but your 11, your 2 and your 9 do become 11, okay? So this is the process, and some of you guys skip some of those steps going through there, but that's the process. That's going to be the same process that we're going to use like in example A over here, okay? So I'm going to put those kind of right next to each other, and we're going to look at what we're going to do here. First things first, I look at, so we're adding these 2 together, okay? I look at the 2 fractions individually, and we're going to just change our denominators. So I just start by rewriting my like fraction stuff here, okay? Rewriting it down below, and then we're going to change stuff. So I have 2x and 5x are my denominators, and we're trying to find a least common multiple, so a least common thing. What?
When can I take that test?
Oh, well, I don't know when you want to.
Do I have time next period or not?
Sure.
Okay, I will then.
Okay. So 2x and 5x are my denominators. Okay, so I'm just looking at the numbers, and I say, like, what number does 2 and 5 both go into? And we're going to have to use 10. So 2 goes into 10, 5 goes into 10. That's the smallest number that I can get. And then we talked about yesterday how you have to have an x in your bottom, okay? So if I look at this, like if I change those both to 10x, does 2x go into 10x? Yes, it does. Like, it goes in there 5 times. Does 5x go into 10x? Yes, it does. Okay, so now we're going to work on changing the top numbers. So I'm going to get ready to change my top numbers. I'm going to leave 3y here, and I'm going to put parentheses like what we're going to multiply him by. Okay, then I'm going to copy my 2z down, and I'm going to put parentheses what we're going to multiply him by. Okay, so these guys just got recopied to here, and I'm going to multiply the top by something as well, okay? So now we look and say, what are we multiplying by? So 2x, to get from 2x to 10x, we multiplied by 5, so I'm going to take it times 5, right? 2x times 5 will give me 10x, so that's what I'm going to multiply by the 3. Why? Okay? Then this guy, if I look, what did we multiply by 5x to get 10x? We multiplied by just 2, right? Times 2, so I'm going to take the top number times 2. Okay, and then I'm just going to, I've got kind of a mess here. Let me erase some stuff. I got some bubbles going on and some bubbles going on. Okay, so now up top here, 3y times 5 is 15y. Okay, and then 2z times 2 is 4z. Okay, and then all we do is combine these under one roof, right? And my bottom is going to be that 10x. Okay, that's going to stay, just 10x. And this top, I'm just going to combine anything that I can. 15y plus 4z. Now, if those were both y's or both z's, I could combine them as like a, like adding them together. But you can't add y's and z's together. So it's just going to literally be 15y plus 4z is how that's going to work. Okay? And that is all that I can do. Okay? That's how you're going to combine stuff. Okay? All right, let's go on to part B. And part B is one where they are trapped. So if we look at these are all going to be simple trinomials. Okay? So, and we're adding again, okay? We're going to do another example down here where we're subtracting, okay? But this one is adding again. And the very first thing that I'm going to do here is when we have things that are trapped, if you want to put that off to the side over here, these are trapped because we have pluses and minuses that are like trapping these terms together, okay? So this is a simple trinomial. And when we break him down, that's the first step that you want to do is to try to break him down. So we want to multiply to get 3, but when I add them, give me -4. So I get like -3 and -1, I believe, okay, is what my pieces are going to be. All right, this guy is also a simple trinomial, so I'm going to multiply to get -6, but when I add them, give me 5, okay, and then the two pieces are going to be x plus 6 and x minus 1, I think, is what will give to me, okay? Then I'm going to go ahead and do my common denominator. Okay, so I still have my two pieces. I'm not going to combine them all into one yet. Just, go one step at a time, okay? So yesterday when we did least common multiple, we would look at each chunk and say, like, what does he need? Well, I know in my denominator I need to have an x minus 3. Otherwise, this won't go into there, right? But he also needs to have, let me erase. He also needs to have an x minus 1, right? So I'm going to put him in here also, okay? And then I'd bump over to this one. So I bump over to this one, and I know that he also needs an x plus 6. And if I look at this, I know he needs an x minus 1, but he already has one, okay? So if I look at all those chunks together, and I say, like, does this go into there? Like, do these two pieces appear down here somewhere? Yes, they do, okay? And then I look at the other chunk and I say, do these two pieces appear down here somewhere? Yes, they do, okay? So I know my common denominator is correct, or my least common multiple is correct. I'm just going to take this guy and I'm going to recopy him over here. X minus 3, x minus 1, and x plus 6, okay? I'm just going to recopy him over here. All right, then what we're going to do is we are going to write our tops, and our top number is 4 and x, okay? So 4 goes here, and I'm going to multiply by what he needs, and x goes here, and I'm going to multiply him by what he needs, okay? So all I'm doing is I'm looking at this and I'm comparing to this. Like I had x minus 3 and x minus 1. Okay, what is he missing that he has down here that he doesn't have up here, right? So he does not have an x plus 6, which means I need to add an x plus 6, right? And if you look at this whole chunk together, right, if I would cancel the x plus 6s, I would be back to this, which is what I had to begin with, right? Like the x plus 6s would cancel. Okay, so I'm just adding those additional x plus 6s in there because that's what he needs from the bottom, okay? Over here, if we compare, like I'm comparing this bottom to this bottom. So he has an x plus 6, he has an x minus 1, that's a here and here, but he needs this x minus 3. So I'm going to multiply the top by that x minus 3, okay? And that's what he does not have, okay? And then I'm going to go and I'm going to do another step, okay? If you can skip steps and like rewrite stuff, that's fine. Actually, you know what? I'm not going to either. I'm going to write it above that. 4 times x and 4 times 6. If I distribute that through, that's 4x plus 24. I'm going to do it up there because I have a little bit of room. If you need to write down below, you can. But I have 4x plus 24. This guy, if I multiply him through, is x squared minus 3x, okay? And then what I want to do is I want to combine it all under one roof. So I've still got these 3 pieces, x minus 3, x minus 1, and x plus 6. These guys are going to stay the same from the bottom. I'm just going to translate them to the bottom. And then all I'm going to do is combine the top, whatever I can combine, okay? So I'm looking at these 4 terms, 4x, 24, x squared, and minus 3x, okay? And I'm going to put the x squared first, right? He's done. I can combine 4x minus 3x, which is 1x, okay? And then I have plus 24. Okay, you can just put x if you don't want to put 1x. And that is all I can do. That is what he will look like when I add them together. Finding a common denominator, adding them together, that's what he will look like. Okay? So there is that. We're going to do another example of that, but it's going to be minus. It's going to be like subtraction. So looking similar, but just having to deal with the subtraction symbol. Here we go. Let's do example 3. Okay, this one is subtraction. Here's what I do when I am subtracting. Okay, to make sure that I don't end up skipping, like when you do subtraction, you have to distribute through the negative or whatever. So whenever I'm subtracting, to make sure that I don't forget to distribute that negative through, what I do is rather than having the negative down here, I change him to a plus, and then I change this to a -4. Okay, so now he's just addition, but I have a -4 up here, and we're good to go. So that will prevent me from forgetting to treat that 4 as though it's negative. Okay, now we're just going to do it like normal. These guys are trapped, so we're going to break them down first, and this is a simple trinomial, so I'm going to break him down to 2 pieces. He is a multiply to get -6 and add to get -1. Okay, and that's going to be like x minus 3 and x plus 2, I believe. Okay, this guy, take a look at him and try to see if you can figure out what he is. He's not a trinomial, and he's not a difference of squares. He is a greatest common factor. He's a greatest common factor. Oop, I just erased that. We're going to pull out 5. So if I take 5 out, I will have x plus 2 left over. Okay, and that's what he will look like. All right, now the very next step is trying to figure out what your common denominator is going to be, or your least common multiple. So when I go through here, I'm saying, I know that I need x minus 3. And I know that I need an x plus 2, so I'm going to put him in here. Okay, I'm going to put all that stuff in here. Then I bump over to the other one, and I say, I know I'm going to need a 5. And I'm going to put the 5 out in front here, because I usually just try to put those single numbers out in front. And then I go through this one, and I say, I know I need an x plus 2, but I already have an x plus 2, right? So I don't need another one, so I can just leave him like that. So as I go through, and I look and say, okay, this is my least common multiple. Do these 2 pieces fit into there? Sure they do. They appear in there. And then I look at this one and I say, okay, does this guy fit into there? Do I have a 5? Do I have an x plus 2? Yes, I do. So he does fit into there. Okay, so my least common multiple is ready to go. And now I just have to multiply my tops. Oh, but first, let's copy him over here. So I have 5. Let's do the same color at least. 5 and x minus 3 and x plus 2. Now, you will get used to doing this, and maybe you can skip steps as you go through this, but don't try skipping steps until you feel like really, really, really comfortable with this, okay? So I'm going to put my x minus 1 up top here, and because we're going to end up multiplying him by something, I'm going to put him in parentheses now, and I'm just going to leave my parentheses ready to go for what he needs, okay? -4 is up top here, and I'm going to put my parentheses for what he needs, okay? All right. Now, let's figure out what he needs. And looking at the denominator that we have now, we have x minus 3 and x plus 2, which appear here and here. But what he's missing is the 5, so we're going to multiply that thing by 5, okay? This one, if we compare, okay, he has a 5 and he has an x plus 2. 5 and x plus 2. He's missing the x minus 3, so we're going to put x minus 3 here, okay? We just multiply by what he's missing, like what's here that's missing that is down there, but that's not up at the top, okay? Like, what does he need to be multiplied by? Okay, and then we just do the math, or do the top, okay? So this guy right here is x minus 1 times 5. So what we're going to do is we're going to distribute the 5 through, and 5 times x is 5x, and 5 times -1 is -5. So that's what that looks like, okay? On the other side, because we changed that to -4, we don't have to worry about distributing the negative at all, right? He's going to go with the 4. So -4 times x is -4x, and -4 times -3 is +12, okay? Final cleanup step. My bottom stays that 5x minus 3, x plus 2. You do not need to distribute it back out and like foil it back out. We're just going to combine this top stuff. So things that can go together is 5x minus 4x, which is 1x, and -5 plus 12 is +7. So you could just leave it as x if you don't want that 1 there. My eraser is so big. You can get rid of that 1 and just have it x plus 7, but that's what he looks like, okay? And that's what simplified is, all right? We subtracted those. We really added those together after we change that 4 to be negative. That's a strategy that I would encourage you to do, just because then you don't have to worry about distributing the negative through, because it's already with the 4. So that's what he'll look like when you find a common denominator. It's a long process. Like this looks like a lot of work, but the more you do it, the more steps that you can kind of skip through, and the more you can do in your head, and then it gets a lot easier, I promise. Okay? All right, not too many problems for homework. I'm going to go to the homework and then I'll come back to that. Okay, not too many problems for homework. You should have 1 through 6 done already. We did a couple of them together yesterday, so like we did number 4 together yesterday. But then on, let's see, what did we do here? I don't remember. Let's just do the odds for here. Let's just do 7, 9, 11, and let's just do 13, 15, 17, 19, 21. Which seems like a lot. That does seem like a lot of problems, but some of them are really, really short, okay? Like their common denominators are not too bad, okay? One thing that I will say on number 9 is that this guy looks kind of funky weird, because we haven't had something like that, but what we can do is we can make this into a fraction. This is 4 over 1, and then you just have to find your common denominator with 5 and 1, right? Sometimes you won't need to multiply by anything on one side, right? Like, I'm just going to keep going with this one, and then I'll let you do the rest of it. But if I find my common denominator of 5 and 1, it's going to be 5. So 5 is here and 5 is here, all right? 2c minus 7, we put what he will need to be multiplied by, and we have 4, we'll put what he needs to be multiplied by. So if I'm comparing this one, he doesn't need to be multiplied by anything, right? So I'm just going to like scribble this out because we don't need anything there. Or you could put a 1 in that spot, right? Like he multiply him by 1. He really doesn't need anything. This one needs to be multiplied by 5. So I'm going to put a 5 there. Okay, so that's what it will look like when your left side, or like when one of your sides doesn't need anything. Sometimes he has everything that he needs, right? So there's how that works, and then you go ahead and finish doing that one and combining your top stuff, okay? So there's a start for number 9, but go ahead and do the odds, and there is that, okay? All right, if you want to continue listening, I'm going to go through this example here. If you're already snowed and you're like, I just want to start on the math, you can come back to this. I don't care, but I'm just going to do one of these. I'm just going to do example 4, okay? So let's look at what this looks like, okay? So if you're still watching, good for you. Here we go. Let's talk about this division symbol right here. This means divide, okay? So, we got a mess. Let's just tackle this top part right here, 1 plus 1 over x, okay? We're going to tackle that top, and we're going to see what he looks like. We're going to find a common denominator. This is like 1 over 1 if we make him to a fraction, just like we did with the 4 down below, okay? If I find a common denominator there, my common denominator is just going to be x. So I'm going to put x, and I'm going to put x, okay? And then I have 1 up here, and I have a 1 up here, and we're going to multiply by what he needs, okay? So like this x right here, or this 1, he doesn't have an x below him, like if I'm comparing those two, so he will need an x. This one, if I'm comparing, he doesn't need anything, so I can scribble this out if I want to, okay? Then this top right here, 1 times x is just x, and this just stays 1. So I have x plus 1 on the top, and I have x on the bottom. So that's what that top part comes out to be. I'm going to box him just so I have him there, all right? Then we have this bottom part right here, which is 1 minus x over y. So kind of the same thing. We've got, this is 1 over 1, and I'm going to find my common denominator with 1 and y, okay? And if you want to do the plus and make that a negative x, you can do that with, like, because technically we're subtracting. So there's how that works, and we'll find our denominator. So our denominator is going to be y, all right? Then we look and say, okay, here's 1 and here's negative x. We're going to multiply by what he needs, all right? So comparing this guy to this y down here, he needs a y, all right? Comparing this y to this y here, he doesn't need anything, so we're going to scribble him out. So right here, this stuff at the top looks like y plus a negative x, or just y minus x over y, okay? So that's what the bottom ended up being, okay? So then we have, last thing, we have this guy divided by this guy, because that's what this bar means. This means division, okay? And we know from the last section that if we're dividing, we're going to keep flip, so that guy gets kept, and we're going to multiply by this guy flipped. So y over y minus x, okay? And then we cancel things that we can cancel, right? But the problem is, like, this x can't cancel with this one because they're trapped, right? Let's see. Okay, this x can't cancel with this one. This one's not trapped, but this one is, right? Let's see, the y's. This y can't cancel with this one because this one's not trapped, but this one is. So what do we do? What do we do when we're multiplying? So if I do this, okay, and I'm multiplying, I can just call that y times x plus 1. Or you can distribute the y through if you want. I'm just going to leave it like that. This bottom will be x times y minus x. And there's that. That's it. Okay, that's what he will look like when you combine them all together. So he still looks kind of ugly, but he looks a little bit better than what we started with, right? We started with a lot of stuff. Okay, here is just one fraction bar. All right, so that was really quick through like what it looks like to, you're combining like terms, but then you're also dividing at the end. So, you know, that's kind of how that works, all right? So if you stuck it out and you made it all the way through, good for you. I'm not going to do this one. It's going to be similar to that. Some things might cancel, I guess, in that case, but we will just go with that top example. That'll give you enough information to maybe figure out some bonus questions at some point. So, all right.